right? So these are the three states and we see right for CloudWatch alarms and automation workflow, how right it looks, how actually we can automate right using these alarms, right? Now, whenever we will get into the auto scaling, right? So that is again we will do right. We will automatically launch right resources based on requirement, right? So based on demand. So how it works, right? First thing, it will be notification, right? So it will notify via right SMS service, say send email SMS, right? Via just a second, give me a moment. So right, so it can write say whenever alarms get triggered, right? So it will send a notification first, say it is sending SMS or email, right, via SMS. Then based on that, right, you can write also write say configure right auto scaling. Say generally when right we get notifications, right, we can also go for say manual intervention, right? We can manually go and create the instances, right? When there is a overutilization of right or breach of your CPU utilization. So you can create more resources right manually. But definitely right when we automate right the infrastructure, so we do it through auto scaling. So it will notify us and auto scaling will get triggered, right? And it will scale in or scale out, right, based on the load. Now, definitely, scale in means it is actually reducing the number of resources, and scale out means it is actually increasing the number of resources, right? So based on demand, right? So if you have right, if your CPU utilization is breaching, right, that is it is going over the threshold, that is actually it will scale out. It will create more instances, that is scale out, right? And definitely, if say there is right a threshold that you have selected right to check the instance state, right, and the instance state is showing you right something, maybe it is not giving you the data or it is right not responding right to certain say requests, right, or health checks, then it you can also recover, right? You can automatically reboot right the instance, right, that is say not responding. Right. So that is easy to recovery and definitely op center, right? You can create an incident tickets right automatically. So if right there is the issue with the instance, still it is not say getting recovered right after reboot or right, then you can also raise right a ticket automatically right to op center. Right. So this is basic right automation workflow, right, that we can go for, right, using say based on right the CloudWatch alarm, right, metrics based on right which one is uh, getting triggered, and if everything is fine, then right it will not go further, right? So but if there is right a requirement, then based on right that alarm, right, it can take right automatic actions, right, based on the state of your resource. So composite alarms. Now what is composite? These are advanced logic, right? So where we combine multiple alarms right into a single state using right your boolean logic and or. So we know right these logics and or. So and is something right that needs both right to be true in the left side and the right side of and, right? So say and or. So or generally needs only one single right say true right condition. In and both the conditions should be true, and in or any one condition should be true to trigger the alarm, right? So the goal here is right reduce alarm fatigue, right, by only notifying right when a set of conditions are met. So like say when we go for right say alarm in, or when we go for auto scaling, so we don't go for auto scaling right just if right the alarm breaches right for a very short time, maybe right it just CPU gave right a spike right for say 2 or 5 seconds. Okay, it just gave you a spike for say 5 seconds. So based on that right short spike, we will not start auto scaling. We will not trigger the alarm. Right. So along with that, what we will see is okay whether that spike is sustained or not. Right. Whether it is sustained. So if the CPU utilization is go say we have a threshold of say 60%, and we say okay if it stays over 60% say for say 2 minutes, so then we will go for auto scaling and it will trigger the alarm, right? Otherwise every time, right, if for say a single spike, definitely right, these are all machines, right? So due to any right mechanical right noise, it can give you a right single spikes every now and then. Now, definitely, every time it gives you that spike, right, for maybe a second or maybe less than that, we should not trigger right alarms, right? It will be a mess then, right?
Mhm.
So we want right other conditions, right, also to make sure that okay they are actually original, they are real, right? So we will say at right that okay if the CPU utilization goes over right say 60% and it stays over 60% for right say at least 2 minutes, then raise the alarm. So that is how right we actually use right these matrices, right? Not with a single spike, right? So actions are taken right only when the composite say alarm state changes. Right? That is what right the and right is. So if right both right it is over 60% and it is right sustained for 2 minutes, then it will raise the alarm, right? Not before that. In the CloudWatch logs, right, storage analysis and querying. Now, let us understand CloudWatch logs. Now, how logs are actually grouped? We have log groups. So here we get right these are top level containers. Right, so like AWS Lambda, my function. So for every function, right, it will have a right log group, and for right every under Lambda, say we have this is again another service. We will see this right later in right the solution architect part. So we will configure this Lambda and we will see that okay every function right will have a separate right log group, right, and under that particular function it will capture right all the logs. So it defines retention and encryption right KMS settings. So based on definitely based on right that we can set right the key management service right to encrypt right and your logs, right? So then we have log stream, right? This is specific source, right, within a group. So single say EC2 instance or Lambda extension, right, ID. So for under log groups, right, we will have log streams, right? So these are for specific, right, instance, you can say, right, granular service, right? For each specific resource, right, we have a log stream, and here it is right a log group. So all the right lambda functions will be there right under the lambda right service. So log events right represent a single record of an activity containing right the timestamp right and raw data. Then from these logs, right, we can query them, right? We can query these logs and get insights, right, and analyze the logs, right, to get right the actual right say make decisions, right? So based on right what actually right being logged. So it is a purpose-built right query language to search and analyze log data right at scale, so interactive and lightning fast, right? So here you see we have log insights in CloudWatch. We can we can run queries, right? So we have right specific predefined right queries over there that we can use to filter right or analyze these logs, right? So here you can see a simple query is there, right? It will find right, wherever it find, right, have this 404 error, right, wherever it matches or the status, right, as 404. No, 404 is generally, right, is not found, right, error. So if someone is trying to access something, right, and if they are getting, right, access denied or not found, right, so they will be seeing 404, right, error. So timestamp, right? Say it is looking for timestamp when it happened. They're looking for the message that got saved with the log, filter based on status, right? As 404, sort by timestamp, right? In descending order, right? And limit for 20 records, right? So this is a simple query that we are running, right, to analyze the logs, right? So this is how, right, we can filter, and definitely in if we want to run, right, more advanced queries, right, we can also use AWS Athena, right. There is another service, AWS Athena, and we can use this Athena to run SQL queries on top of, right, all these logs, right. And we can store these log files, right, in S3 bucket by default also, right. The AWS stores all the logs in S3. Right. So definitely when they are storing it in the default buckets, right, that AWS manages. So the retention policies, right, will be actually, right, implemented, that okay, it will be, right, stored for 15 days, like what we have seen, right, for 1 minute metrics, and it will get deleted right after say 15 days. But if we want to have, right, we want to sustain those logs, we need to, right, push them to other, right, custom S3 buckets, right. So whenever say whatever service we create, we get the option, right, that okay, where we want to actually store, right, the logs. So whether we want to, right, push it to our custom S3 buckets. So
Yeah. So this query is like a select statement as well. Is that right?
correct, correct, correct.
Okay.
Yeah, it is just like select.
Uh,
Yeah, it is selecting these two fields, right? Timestamp and message. So then we have metrics filter. So what is turning, right, logs into metrics? Now definitely pattern, right, match log data and convert it into, right, a CloudWatch metrics. Example search for error, right, in application logs. So if found, increment, right, a metric called error count, right. So you can then create an alarm, right, based on filter, right, derived metric. Now you see, uh, uh, we can create, right, these custom, right, metrics from these logs. So we will have that okay, if right, if the error count, right, goes say over 5, then raise an alarm. Right, so see what it is doing is it is looking, right, at the log. It is reading the log, analyzing the log, and extracting, right, the count of that particular word. So if it is going over, right, certain threshold, that okay, if error count is, right, the number of times, right, the error word, right, appearing, so that is the error count, right. So it's right over say 3 or 4, raise the alarm, right, because that is very frequent, right. So that should not be happening. So based on such, right, data, right, we can also, right, raise or trigger, right, these alarms. So definitely, right, when the developers they are writing the code, right, they also, right, enable the logging, right, in their program, and they actually store, right, specific messages, right, with that log based on the error type, right. So definitely, if that error type, right, if there is a, right, say we are right, filtering these logs, right, and we are matching patterns, right, in these log files, and if we look for those error types, right, definitely we can see that the frequency of that error, and based on that, the developer will get alerted that okay, this right error is getting, right, triggered, right. So again and again, right, it's maybe within 24 hours it went more than say 5 times, right. So I mean, based on that, they can have a look, right, in their program, and they can fix, right, the issue, right. Then event monitoring, right, orchestrating real-time responses. Now let us see what is event, right, monitoring, and here In AWS, we have AWS Amazon Event Bridge. Now, the modern right event bus, what it is, formerly right CloudWatch events, a serverless event bus right that makes it easy to connect applications using data from AWS services. Right now, what is events? Right, it is change in environment, say instance stop. So it is a state change, right? Say a resource that was in say running state and suddenly it right someone just stopped it, so there is a change right in the events, change in the environment resource, so it is an event right that took place. Now again maybe when it was in stopped state and someone just started it, right, someone terminated it, so these are all events right that is actually taking place right in the environment. Now event bridge right or now the event bus, it can actually monitor for such events, right? It can monitor the entire environment for such events. That okay, whatever changes right is happening in the environment, it can say note it down, right? Or it can right monitor and then it can send notifications, right, based on right your conditions. Now rules match events, right, and route them to targets. Now right you have to set right the rules right for the event bus or your event bridge. Now in rule what will be there right is okay what you are actually monitoring, right, so what state you are actually monitoring. So maybe for here for this event right that instance state right was in running state. Now when right say rule says that okay if the state changes to stop, right, then trigger SNS and send right this state change notification to email, right. So it will trigger right, it can trigger say lambda function, it can trigger right SMS SQS right or any other event bus, right, so any other service that you are actually right supposed to select for what particular right rule you have selected. So for example, when we are going for say EC2, so EC2 is stopped. Now our rule was that okay, if the EC2 instance state changes, then okay, send right the alert right or trigger the SNS topic, right? So SNS service. So this SNS right is a simple notification service. Now SNS will get triggered and then SNS will send right notification right via SMS or email to all the subscriber of that SNS topic, right, or of that say SNS service, right. So that is how right we generally create right use the event bridge, right. So we can right create a workflow right that will trigger based on certain event taking place, right? So event is just right any change you can say right that is taking place right in the environment, right? So Amazon SMS notification, how right is getting the SMS notification. It is actually a pub sub model that there will be publishers right to the SNS right service, and there are subscriber to this SNS service, right. So publishers will be publishing the message and subscribers will be receiving that message, right. So here when we see the event bridge, right, it is going to send right say notification or right to SNS. That means so publisher is event bridge, right, or event bus, right? It is the publisher, and who will receive the notification or right the that email or SMS are the subscribers, right, of that SNS service. So it is a pub sub right model that it follows, right? SNS. So it decouples the publishers right from subscribers, send right one message to multiple destination right simultaneously. Definitely, we can have thousands of subscribers, right, and we can have a single a publisher. The publisher will right publish the message to the SNS topic, and then whoever is actually subscribed to that SNS topic will receive the notification, right. So that is how right publisher models work, and then endpoints, right? Endpoints are actually where you are actually right say pushing right the notification, right? So subscribers will be receiving right the notification via these endpoints, right? So it will be say supports right email, SMS, your HTTP or HTTPS requests, your Lambda functions can get triggered, your SQS, the simple queue service can get right, and mobile push notifications, right, in your mobile devices also, right? So through push notification. So these are different endpoints, right, that actually can receive that message, right? Then fan out, right, is another right way. So it's reliable delivery, right, at scale. So perfect, right, for notifying both ops, right, teams and triggering downstream automation, right? So fan out is basically right. It is sending right to all the subscriber right simultaneously, right? So uh, uh, whatever right what all subscribers right subscribe to that topic will be right getting the notifications, right? So down the line. So coming to the SysOps best practices. So detailed monitoring, right? So enable 1 minute EC2 instance, right, for critical production instances. This is way better, right, than 5 minutes, right? So definitely for very business critical application, right, it should be right less than 1 minute, right? Maybe every second, right? But definitely for production level instances, right, at least 1 minute, right? Frequency should be there, right? Interval for the logs, right? Alarms use right missing data settings right wisely to avoid flapping right alarms. Definitely, right? Missing data, right, should not be there, right? You need to always check whether the data, right, is accurately and correctly, right, getting sent, right, to CloudWatch. Otherwise, definitely, if there is no data, right, then definitely it will, right, not raise the alarm, even if, right, the condition is met, right? So naming again, use consistent namespaces, right, and dimension tags, right, for easier querying. So definitely, when we create our resources, right, we should actually have multiple tags, right? So for each resource, we can actually create 50 tags, right? 50. Now 50 tags are actually there, right, to filter, right, our resources, right? When we right query for particular resource, right? So based on right their tags. Now whatever right resource we are creating, it is always right better to use the right specific namespaces, right, and right to tag the resource itself so that we can easily right pinpoint based on right the dimensions and the namespaces, right? Or we can categorize or we can group the resources right based on certain tags. Right. Again, set right cost is set up CloudWatch metrics frames, right, for high volume data export to S3. You see, right? So we can export the data right to S3 to make it persistent, right? To store it right above the minimum right retention period. Right. So these are some of the right best practices that we need to follow. So now, first thing what we will do is we will right launch our EC2 instance. Right.
Oh, okay, sure.
So yep. No. Let me first demonstrate, right? And you
Oh,
can
okay,
follow, right? The same.
okay, I'll follow. Okay.
Yes. Follow the same.
Yes.
So first we'll go to EC2
Okay.
and we'll click on launch instance. Launch without a walkthrough. And for this instance, we will call it monitoring instance. Say monitoring instance. We will go with Amazon Linux, the default AMI, and we'll keep the default instance type also. Keep the default instance type.
Yeah, my instant type is T3 micro. So this one is still two, T2. So maybe that's why it's
Two,
showing one.
right?
Yeah,
Yeah,
mine is
for me
three,
it's
two, three,
yeah,
T3.
it is T3. Correct.
Yes.
So yours is a new account, right? So in the new account, you have a better CPU, right? For
Okay.
free tier. Yeah, yeah. So here we will go with without key pair. Okay, we will proceed without key pair. Okay, and then here in network connection, we will not right say allow anything. So just you can go with only SSH.
Default.
So it
Okay.
will create, yeah, it will create a new security group and it will keep the SSH traffic allowed. Okay, so just keep this and that's it. We don't have to do anything else here. We will click on launch instance right directly. We click on launch instance and once we launch the instance, we will click on the instance ID and in the from the left pan, we will click on instances. Left pan, we click on instances. Then we will select this instance. Okay, so once we select this instance, then we will take SSH. Okay, so we will be using instance, right? Instance connect. So we will click on connect here and we will keep EC2 instance connect selected and we will click on connect. Okay, so here we go. We got connected. Done. We got connected. Wilson
Yes, yes, I'm connected right now. It's not connected. Yes,
is connecting, right? Okay.
yes,
You got connected, right?
yes, yes. I am. Yes.
Okay. Now I want you to just open a duplicate tab. Okay. I want you
Okay.
to open it. So you just need to right click on your existing one
Okay. System
and
one.
then
Okay.
click on duplicate.
Duplicate. Okay.
Click on duplicate. Yeah.
Okay. I've done
So
that.
you got one more terminal, right?
Yes.
Okay. Now you can go back to the previous one.
Hmm.
Go back to the previous one, and here I want you to. Okay. Okay. First here. Okay. You can go to the second one. You can go to the
Second one.
second one
Mhm.
and run top. You can run top. You can run top command.
Yeah.
Or I think just a second. Stop will be stop is not there. Okay, fine. Top is fine. So here, right, it is showing us right the performance metrics here. Okay, what is the current usage? So CPU
What
percentage currently you see.
What do you type to quit? Do you press Control C or when you type the top?
No, no, just top. Just go for top. You just
Okay.
have
Sure.
to use this. Yeah.
Okay.
Currently you see what I'm seeing, right?
Yes. Yes.
Okay, then it's fine. Okay. So currently the CPU utilization is nearly you see currently in use right is completely idle position. You see that right now. What we will do is we will go to the previous terminal. We'll go to the previous tab, and here we will install right an application right that will increase the stress right of the CPU. Okay,
Okay.
so we will run sudo yum install stress hyphen y. Okay, sudo yum install stress space hyphen y.
Space -y. Okay.
Yep,
Okay.
enter.
Mhm.
So it's a tool, right, using which we can actually increase the stress on our EC2 instance.
Yes. I've
So
done that.
yeah, okay, done.
Hmm.
Clear the screen, and now we will run the command stress hyphen hyphen CPU, and here I will give one, right, because I have a single CPU. You can use two. Okay, you can use two. I'm using
Okay.
one, and time out to say 150 seconds. Okay, so this is in seconds. Okay, 150 is in seconds.
150 seconds. Okay.
So it is going to increase, right? It will utilize your right core. Okay, so constantly what it will do is it will do some calculations. Okay, to increase your CPU right
Uh,
utilization.
okay.
So for you, you should keep it two.
2.
So you
Okay.
can hit enter. Yeah, you can hit enter,
Mm-hmm.
and you see here it will just stay in this position, and we can move back to the other terminal.
To the other. Okay.
And now you see here, earlier it was showing you 0, right? Currently
Mm-hmm.
you see here, it's over 98%, right?
Ah, okay. Mm.
You can see that. For you also, you can see that same thing.
Yeah, 100. Yeah,
Yeah.
199. Yeah.
So that is how right monitoring right actually help us to monitor right distribute. Definitely, if we are running applications right in such server that is going right with CPU utilization is going over 90% or it's 98% right, and we have critical server right, it will fail right
Mm.
if end users if they try to connect right to that server, it will generally right will fail if it gets right huge traffic, right? It will just crash. So that is how right we can simulate. So now you can suspend this with Control C. Just do Control C.
So it's the same thing we'll see on CloudWatch, or you still come back, you still come to that level later.
Uh, yes, yes, definitely. We will use right CloudWatch also to monitor
Ah, okay,
this,
okay,
right? Yeah, utilization. So here also, let me show you. If
Um,
you go to monitor here,
how do you stop that?
right?
Are you clear? How do you stop the stress? Do you press
Yeah, yeah. Control C. Just go for
Control
Control
C?
C.
Control C.
Yeah,
Okay,
Control C.
okay,
And now you
okay.
can
Okay.
move back and you see it is again back
To 0.
to
Okay.
idle, right?
Okay. Okay.
Now you can go back to your instance page.
Mhm.
Go to your instance page.
Okay. Sure.
Yep. And then you see at the lower half, you have the monitoring tab.
Hmm. Yes.
Click on that.
Done.
Right. So you see here, you have the CPU utilization.